I see something here. I enable the editing of surface feature, and I could go as far as from here. I will be very, very quick, so I'm not precise at the moment. I'm not precise, but I will show you an area which is quite bright and on top of everything. Okay, and I call it rain. Okay, so we have something like this here. Then faculae. Faculae are very bright spots, but differently from rays, they are not blue, they are reddish or yellow. For example, here we have a very bright yellow area. And if you turn off the enhanced base map, you can see that we have a very strange ground over here. There are pits, irregular pits. They are not craters, they are pits, and they are scattered all around this bright area. So this is a volcanic area. This is a pitted ground that maybe has a volcanic origin and probably an explosive origin. So what we do with surface features is just tracing the border of this area like this, more or less. You don't have to be precise, just to say it's here, okay? And call it facula. Facula in Latin means bright, very bright spot.
Yeah, this is what I was gonna ask. Yeah.
Okay. Facula is singular and faculae is plural. And
a question. Don't you think this thing is very difficult, like digitizing all these things? There is no any other automatic way of doing it, like
automatic way of digitizing.
it, like instead of doing it
Well, there are some people who studies machine learning tools to automatic map things, but actually what a geologist does is interpreting the surface and the stratigraphy. So for us, it's very important to do with our own hands and our eyes, because while we draw it, we don't just draw. We don't want to do a nice drawing. We want to understand the history of this area. So by drawing it, we are saying this is on top of this, and this is on top of that, and this is younger, this is older. And this is very difficult to get with an automatic mapping. So a geologist really needs to interpret the surface and make with a map with his own hands. We did a lot of maps, and if you're interested, I can give you the links to the maps of Mercury.
Sure.
But I know
it's
a tough job. Both Jack and I did our PhD doing 5 million kilometers square of map.
Yeah, I understand this is very difficult because I've been involved in projects like, land cover, land use. And we use also manual digitization of doing this thing, but it's much, much easier to digitize like this kind of thing. But here it's very difficult because for that areas, you can see this vegetation in the area, this residential area, for example, this is urban area. But here it is very difficult to distinguish different classes.
Yes, I know Mercury, the most difficult thing on Mercury is distinguish between the ejecta and the surrounding terrains and between different units, because the surface is very, very uniform. The texture is very uniform. So you have to practice your eye and go on with that. Yes, it's tough, but that's what we like.
But it's very interesting, actually. It's very interesting and enjoyable as well. So thank you very much.
Okay, you're welcome. And speaking about faculae, I told you that they are bright spots, but if you look at the area, there are other bright spots. For example, this crater on the far southeast and this central peak here. They are not faculae, actually. They are other features that look very bright. A facula is not only bright and yellow, it is also associated to a very peculiar morphology. For example, to the far northeast of this map, you have these pit here. You can see it's not a crater because it's very irregular, and it does not have a raised rim. It's just a pit, okay? And it's surrounded by a very bright terrain. This is a volcanic vent surrounded by a facula. The facula is the bright terrain generated by the explosion of this volcanic feature. So even in this case, we can map the facula with the help of the enhanced color-based map, and we can stay a bit larger like this. So in this case, the map ends here, so I will do something like this. Okay. We call it a facula. But then you have to, let's say these are the last features you have to draw because they hide what's beneath. So I usually turn off this layer and concentrate on the morphology. In here, there are several interesting things. There is a volcanic vent. There is a crater. So if you want to draw this volcanic vent, we need another linear feature. It's not defined here. So if you're interested in drawing this vent, just let me know and we will create together a symbology for that, okay?
Yeah, I see it now, but did you do any example of the linear features? Maybe I have missed it.
Linear features.
Yeah, did you do some?
Okay, linear features, yes, I did. The linear features are these crater rims. Crater rims are linear features, not geological contacts. They just define a morphological limit, not a geological limit. So the crater rim has to be drawn as a linear feature, not as a contact. This is a linear feature.
Like that I made earlier.
Yeah, and this is another linear feature because it's another crater. I turn off my contacts. If I turn on my contact, you can see the contacts are here. This is the central peak, the floor, and the ejecta. Okay, turn off the linear features. So the geological contacts are these ones. Because these are all crater materials, You have to concentrate on crater materials, not on morphology, but crater materials. It's the same crater, okay?
Okay.
If you concentrate on morphology, then you need the linear features to say, hey, here you have the crater scarp, okay? Then,
so when we're doing craters, we're doing linear features. Otherwise, we're doing contacts, yes?
When you do the crater rim, you do the linear feature. If you have to do the crater geological units, you have to use geological contacts.
And for example, what would be the unit here inside the crater?
Yes, exactly. If I turn on my units, I put some point features to say that this is a floor, this is a central peak, and these are the ejecta.
Yeah.
In the end, let's say more or less in half an hour, we have to try to build our polygons. Okay?
Okay.
I will show you in a while. And it's very important that you have closed your contacts and put your point features in each polygon. So To show you another example of linear features, this is a degraded crater. An important thing is that geological contacts must always be closed against each other. They have to touch each other, otherwise it won't create a polygon. While linear features can be open, it doesn't matter because they won't create a polygon. In this case, I created these linear features to say that I can see a crater rim here. I can see a degraded crater rim here, but I almost don't see anything over here. Maybe I can try to draw something over here. Maybe I see something, but I will always keep my degraded symbology, which in this case is called crater buried, but I also use this symbology for degraded craters, okay? So these are linear features and they are open. They don't need to create polygons, while the polygons will be created by the geological contacts. I will go on with my mapping, and if you have any other question, please interrupt me whenever you please.
Yeah, I have another question, Valentina, about, for example, in the case of Rashmaninov basin, like for example, an old basin like this one with that have multiple rings, how they will be mapped in this case, the floor and the ring. For example, we have here many rings. So how are we gonna map the floor limit?
So we have a central peak rim and the rim, actual rim of the crater, okay? So this is the rim and this is the central peak. So if we speak about geological contacts, I will turn off linear features so I can concentrate on geological contacts. I will draw, just a moment. So I will draw the border of the ring like this at the base of its scarp.
So that's gonna be considered as the floor limit.
This is the inner ring floor limit. But what I'm doing now is not the floor. I'm concentrating on the ring. So I want to close the ring unit because this central floor is open, as you can see from here. So I will go around here. I will stop here because I'm certain here, but it's approximate from here and here. I think, I don't know exactly where to put my contact here. So I will go on like this.
So that's the central peak.
Central ring.
Central ring. And for the floor, how are we gonna put the floor limit?
It's automatically drawn because you can see now. I will now finish my central ring, and then I will show you the floor. So, okay, I will finish my ring over here. Let's say over here. I'm not very precise, but when we do real geological map, we have to be precise. Okay. So now, Maisa, can you see that I mapped the ring here?
Yes.
So this will be a polygon, right? And this will be the polygon of a ring, which is the ring of a larger crater, which is a very fresh crater, let's say. I would call it a C3 crater because I can see the rays, the ejecta. This is a C3 crater. So both its ejecta and the ring will be classified as C3. So I will stop drawing this. Okay. And start. I just want to put a point feature here to say that will be classified as C3. Okay. Then the floor of the crater is all this, right? I already created the polygon within it. So if I draw a line all around here, the floor will be done.
So the floor is the part between the central ring and the rim.
The floor is the part between the rim
and the central ring.
And the center of the crater. Doesn't matter the ring, because the ring is already mapped. You already have a line here. You already have a line here.
Yes.
That's the ring. It doesn't matter. So we just have to draw the contact between the rim and the floor. Okay. So I will draw it and we show you at the end the output. Again, I'm very, very quick. I might not be precise. It's normal when many mappers do the same area. It's normal to see different outputs. Now you see, I'm not going around the rim because I see this hammocky area. So I avoid that. I will stop here. Certain. Then I have to close it right there, right to the south here. Okay. Approximate. Then I have to continue it here. I will do the whole border. More or less up to here because I see a hammocky region. I'm not precise, okay, but just to say this region is more hammocky. I will say it's approximate. And then go on here. The region is smoother. So I go on like this. Following the rim. I will stop here because it's a bit hammocky.
Yes. So the floor in this case is gonna be considered the part between the rim and the center, whatever, if we have or we don't have a central ring.
Exactly, whatever. You have just to distinguish between smooth parts and hammocky parts. Can you see it?
Yes.
So we just need to close this northern part of the floor. It's open. We need to close it.
Yeah.
So I will draw. So if you're drawing this floor, don't worry if you're doing different than me, because I'm doing it very, very quick.
Yeah, it's not a problem.
Okay. So now you can see that the floor is clear. It's beneath the rim, but you have some areas which are different from each other. Some are smoother, some are hammocky. Okay. Now I will define better the hammocky regions. So, for example, I don't know, here maybe, very, very rough drawing, very rough drawing. Why doesn't it snap? Okay. Do you have snapping activated?
Yes.
Okay.
For me, yeah.
It's very important. Otherwise, you won't close your contacts.
Mm.
Then we will approximate. Okay. Sometimes you may need to change your vertices. Now I can't find the button to change my vertices, but should be somewhere.
Mm-hmm.
Oh, here it is. I just wanted to move this vertex over here. Okay. More or less, we have something. Now I will continue. No, I want to draw the linear feature of the rim of Rachmaninoff. Remember, the line that draws the rim is not a geological contact. It's a linear feature. I did wrong. Oh no, maybe I can continue like this. Stop. And then begin from here. This crater is it has a lot of terraces, okay? So you can even overlap with the rim linear feature.
And actually, I have another question. If we are not sure about the crater floor limit, can we still draw it with just continued line?
You can draw with approximate contact.
Mm-hmm.
If you're not sure, you use the approximate contact.
Mm-hmm.
So this crater is very, very large. It would need a lot more units to be used. Okay. So these 3 units are not enough. But for now, okay, like this. We have to accept what we have. So if I turn off the base maps, now it's pretty clear. But the rim is not so continuous because it has some terraces. So I did like this.
Yeah. And concerning the crater ejecta, sometime we found a large crater but with a small ejecta and small crater with large ejecta. So is that okay?
Yes. Yes.
So the ejecta doesn't depend to the crater size.
Yes, they depend on it. And maybe if you find a large crater with small ejecta, you have to question yourself, am I doing right? Maybe I'm not watching the right base map. Or maybe you're watching a very old crater. Or maybe your scale is just too small to see where the ejecta end.
Yeah.
There are many reasons. There are many reasons. In general, the continuous ejecta blanket is as far as 1 crater diameter. So if you're not sure where the ejecta end, just consider the diameter of the crater and go as far on the map and see if you see something there.
Yeah, that's right.
Okay. I will stop editing these and edit the units because I have several polygons over here. So I will have a smooth crater floor here, hammocky crater floor here, smooth crater floor here. I'm going, now I'm going by memory because, okay, smooth, and this is hammocky. Very important that you start defining your point features because we will have to create the polygons. Then have another, not smooth, this is already defined. This is hammocky. And okay, this is done. Now I need the ejecta, but I won't draw them because I want you to find the ejecta of Rachmaninov. Okay.